What is simulator? Simulator is a computer program that models or simulates some aspects of a real life situation. What can be the real life situation? It can be flying an aircraft or making circuit on PCB, or it can be programming microprocessors. And that computer program can be manipulated to observe the outcomes of different assumptions or actions without exposing the experimenter to any danger or risk. 8085 microprocessor simulator. It is a computer program which allows us to carry 8085 programming so that it can be tested before using actual hardware module. It's a cool way to learn and write 8085 assembly language programs. The days are gone when you are punched in the assembly language in the hex format and hoped nothing went wrong. The salient feature of 8085 simulator. It provides you full facility to simulate or debug your program. You can view the state of memory register, flags and stack pointer. You can modify any memory location, register and instructions. You can set breakpoints. You can modify instructions at runtime with syntax checking.
Now we'll see how to use a 8085 simulator to do programming on it. Here I am using a simulator easily available on internet, namely GNUSim8085. Firstly, let's just go through some main fields of this simulator. On the left side, we have status of all registers, program counter and stack pointer status. Beside the register block, we have flag registers, which reflect the status of sign, 0, auxiliary carry, parity, and carry flag bits. And below all this, we have a decimal to hexadecimal or hexadecimal to decimal code converter. On the right side, we have two main fields, stack field and memory field. The stack field reflects the data on the stack, and next is the memory field, which reflects the address and data present at this addressing location. We can even move to any location in memory using start, where if I specify 2001, the specified address appears and I can alter the data at this location by double clicking on it. Note that data here is in decimal format and not in hexadecimal format. So it can be converted to decimal format using the code converter available on the bottom left side. Let us now take an example to explain how to work on this simulator, wherein we'll write a simple program to add two 8-bit numbers. If the resultant exceeds 8 bits, we store the overflow in register B to give a 16-bit result, which we'll store in stack. For example, FF in hexadecimal added with 0F in hexadecimal gives us a 16-bit hexadecimal number 010E. The 8085 program for the above statements looks something like this. First of all, let us move to the location, memory location 2001H, wherein the first operand has been stored, which is FF, and the decimal value for it is 255. And in the next consecutive location, the second operand, which is 0F, has been stored, whose decimal value is 50. We can execute a program by directly executing it by pressing F9 or moving to assembler where we have execute button, or we can even go for step-by-step execution of 8085 code using step in code button. So let us start the step-by-step execution of our program so that we can get insight how the various registers and flags are being affected with the execution of each statement. With the execution of halt instruction, our program execution terminates and our result will get stored in the stack as shown in stack field. At the following stack location, we have hexadecimal number 010EH, which is sum of the two numbers FF and 0F, which is equal to 270 in decimal code, that is the sum of 255 and 15.